Welcome to the DIY Honda Garage channel. The DTC code P0339 indicates an intermittent interruption in the crankshaft position CKP sensor circuit. This error suggests that there is an issue with the electrical signal from the CKP sensor to the powertrain control module PCM, or the electronic control module ECM. The CKP sensor is located near the crankshaft and is essential for providing the engine's rotational position. It plays a critical role in engine timing and ensuring smooth operation. When this DTC is flagged, it's crucial to proceed with a systematic diagnostic approach to identify and rectify the root cause of the issue to prevent potential engine stalling or poor performance. The crankshaft position sensor, CKP, is vital for the engine's operation, providing real-time data about the crankshaft's position and rotations to the ECM or PCM. It is typically situated at the front of the engine, adjacent to the crankshaft itself, secured in place by bolts. This sensor helps in determining when to fire the fuel injectors and ignition coils, which are crucial for optimal engine performance. An intermittent interruption means that the signal may be sporadic or entirely cut off, leading to issues like misfiring, stalling, or a failure to start. The position of the CKP is strategically chosen to access the crankshaft effectively while remaining shielded from potential damage. Moreover, both the ECM and the CKP sensor connect through wiring, making these connections critical for proper operation. Several factors can trigger the DTC P0339, affecting the CKP sensor's functionality. Firstly, poor connections can arise from corrosion or dirt, interrupting the electrical flow. Secondly, loose terminals can lead to intermittent contact during engine operation. Vibrations can further exacerbate this issue. Thirdly, if the CKP pulse plate, which interacts directly with the CKP sensor, is damaged due to metal debris or wear, it can create similar disruptions in the sensor signal. Additional factors could include wiring issues along the circuit that connects the CKP sensor to the ECM or PCM, highlighting the need for a thorough visual and electrical examination. Each of these issues can significantly affect engine performance and alignment. When the DTC P0339 surfaces, a host of symptoms may become apparent during vehicle operation. One of the primary symptoms is engine stalling, which occurs when the CKP sensor fails to relay the correct information to the PCM, leading to unexpected shutdowns. Another observable symptom is misfiring, where the engine may struggle to maintain a stable RPM, often resulting in rough idling or acceleration issues. Drivers may also experience difficulty starting the engine, as the PCM may not be able to correctly time the ignition and fuel injection if it doesn't receive accurate data from the CKP sensor. Any combination of these symptoms may indicate an electrical fault or sensor failure, necessitating detailed diagnostics to resolve the issue. The first step in troubleshooting DTC P0339 involves turning the ignition switch to the on position, ensuring that the vehicle's electrical systems are powered but not started. Next, use the HDS, which stands for Honda Diagnostic System, to clear any existing diagnostic trouble codes from the system. This step is crucial as it resets the system, allowing for a fresh assessment. After clearing the DTC, start the engine and let it idle for about 10 seconds. This idling period allows the engine management system to gather necessary information about the crankshaft position sensor, providing a clear baseline for monitoring its functionality. This initial step sets the stage for the following diagnostics and ensures that you are working with the most accurate data. After allowing the engine to idle and recording the initial information, the next step is to monitor the OBD, onboard diagnostics, status through the HDS. This status feedback will indicate whether DTC P0339 persists. If the HDS shows that the DTC has failed, it is essential to move to Step 7, where you will check for any poor connections or loose terminals related to the CKP sensor and the PCM. If the HDS indicates that the DTC has passed, you should move to Step 5. Conversely, if the HDS displays not completed status, continue idling until a definitive result appears. This systematic checking ensures that any present issues are addressed in an orderly manner, providing a clear pathway for resolving the DTC. In this step, the vehicle needs to be test-driven for several minutes while adhering to specific recorded freeze data parameters, such as engine speed and vehicle speed. This driving test helps simulate various operating conditions that the CKP sensor may encounter during regular use. By doing this, you can determine whether the CKP sensor and its circuit perform reliably under these conditions. After the test drive, it is crucial to monitor the OBD status again through the HDS. Just like before, assess whether the HDS indicates a failed status or if the system has passed. This step is pivotal for identifying intermittent issues that may not surface under idling conditions alone, thus providing broader insights into the CKP's performance. The next troubleshooting step is to examine the electrical connections thoroughly. Begin by checking for poor connections or loose terminals at critical spots, including the CKP sensor, ECM, and PCM, as well as the associated engine and body ground wires. These points are prone to corrosion, damage, or simply becoming loose over time, which can disrupt the flow of electrical signals essential for proper sensor operation. High-quality connections are imperative for the CKP sensor to relay its accurately processed data to the PCM, ensuring that all engine components work in harmony. Performing electrical checks, including visual inspections and continuity tests, can reveal any faults in these connections that could lead to DTC P0339. If no issues are found, you would proceed to the next step, further honing in on potential sources of intermittent interruption. In this step, you will need to remove the oil pan to access the CKP pulse plate. The CKP pulse plate is a critical component that interacts with the CKP sensor. It generates the signals needed for the PCM to interpret the crankshaft's position. After removing the oil pan, inspect the pulse plate meticulously for any signs of damage or metal debris that could hinder its functionality. Damage to the pulse plate can disrupt the signal needed for proper engine timing, leading to the P0339 diagnostic code being triggered. If you find any metal debris, ensure to clean it off safely to prevent future complications. If you identify any damage to the pulse plate, you may need to either clean or replace it, which would resolve potential issues before moving on to the next steps in the diagnostic process. After checking the CKP pulse plate for damage, the next logical step is to determine whether it is indeed damaged. If you find that the pulse plate exhibits any form of damage, whether it's bends, breaks, or significant wear, it will need to be cleaned or replaced entirely. The integrity of the pulse plate is paramount because any irregularity can disrupt the CKP sensor's ability to function correctly, resulting in intermittent signals to the ECM or a PCM. In contrast, if the pulse plate is found to be undamaged, you can proceed with replacing the CKP sensor itself in the following steps. Each decision at this juncture stems from thorough inspection and assessment, ensuring that no stone is left unturned in the diagnostics. At this point, you will need to turn the ignition switch to the lock 0 position to safely replace the CKP sensor. Replacing the CKP sensor is crucial if previous steps indicated that it was the source of the issue. Carefully follow the manufacturer's specifications when sourcing an appropriate replacement CKP sensor to ensure that compatibility and quality standards are met. Upon removal of the faulty sensor, install the new one with precision, making sure that all connections are secure and that it is correctly fitted in the designated location. A proper installation of the CKP sensor is vital for successful communication with the PCM, helping to prevent future occurrences of DTC P0339. After replacement, you'll move on to resetting the system and verifying its functionality. Once the CKP sensor is replaced, turn the ignition switch back to the on/to position to power the vehicle's electrical systems. The next step is to reset the ECM or PCM using the Honda Diagnostic System, HDS. This reset is critical as it allows the newly installed CKP sensor to be recognized by the engine management system, ensuring that any learned parameters are recalibrated effectively. After resetting, perform the ECM-PCM idle learn procedure, which helps the system accurately gauge the baseline idle speed and conditions of the new sensor. This procedure ensures that all components work together efficiently and helps optimize engine performance. Following these steps proactively prepares the vehicle for final testing and verification of repair. Following the resetting and idle learn, it's necessary to execute the CKP pattern clear and CKP pattern learn procedures. The CKP pattern clear will erase any existing patterns stored in the PCM related to the previous sensor, thus preparing the system to register the new CKP sensor's readings. Next, the CKP pattern learn procedure should be conducted, enabling the system to establish a fresh set of patterns that correlate with the engine's operational characteristics and the new sensor. This learning process is essential to ensure that the PCM can accurately interpret signals from the CKP sensor, leading to improved engine function. It confirms that the vehicle is ready for operation under real-world conditions, making sure the underlying problems have been addressed thoroughly. Now, restart the engine and let it idle for another 10 seconds. During this time, it is essential to closely monitor any new diagnostic trouble codes that may appear in the HDS. By checking for pending or confirmed DTCs, you can gauge whether the repair procedure was successful in resolving the original issue. If DTC P0339 reappears, you need to revisit previous steps to ensure no underlying connectivity or sensor issues remain unresolved. However, if no DTCs show, it indicates that the CKP sensor and associated components are functioning as intended, marking the completion of the troubleshooting process. Correct assessment at this stage is crucial for ensuring long-term reliability and performance of the vehicle. In closing this repair process, it is essential to validate that all repairs undertaken were successful. The primary indicator of successful resolution will be the absence of any recurring DTCs, including P0339, during the diagnostic checks. This final step guarantees that connectivity and sensor issues have been fully addressed. It's imperative that the vehicle demonstrates optimal performance without stalling, misfiring, or confusing, or any other symptoms previously observed. If any other DTCs appear, further troubleshooting will be required for those new issues. Proper validation at this stage assures that the vehicle is road-ready and that the driver can feel confident in its performance. To minimize the chances of encountering DTC P0339 again, preventive maintenance plays a vital role. Regular inspection of the CKP sensor and its connections should become part of routine vehicle checks. Ensuring that all electrical connections remain clean and free of corrosion is essential for promoting a reliable signal path from the sensor to the ECM. Additionally, periodically checking engine and body ground locations can prevent erratic sensor behavior caused by lost grounding. Keeping these areas maintained helps uphold overall vehicle integrity. By integrating these maintenance practices, you can preemptively mitigate issues that may trigger DTC P0339 in the future. In summary, troubleshooting DTC P0339 for the Honda Accord models from 2008 to 2012 requires a systematic troubleshooting approach. Each step builds on the previous one, providing a thorough understanding of possible issues related to the CKP sensor circuit. Identifying poor connections and ensuring the functionality of the CKP sensor are paramount to resolve the error effectively. Following the detailed steps outlined is vital for restoring engine performance and preventing future occurrences of this DTC. Moreover, implementing preventive maintenance will bolster the reliability of the vehicle's engine management system. Understanding the importance of each component and its role significantly aids in maintaining vehicle longevity and performance. Please like and subscribe to the channel. See you next time!